This is going to be a very short lesson on jet streams. It really goes with kind of the other wind um, sections that we did, but I didn't have time for it then, so we're just going to do it in a separate little lesson. Jet streams are strong currents of wind located at about the tropopause. Okay, so strong currents of wind located at about the tropopause. Think about them as like a river of wind at the tropopause. Again, tropopause, remember, is the boundary between the troposphere and the stratosphere. So it's a strong river of wind at that level. You can see in the pictures here, there are four of them, two in the northern hemisphere and two in the southern hemisphere. We have the polar jet and the subtropical jet. And you can see about how big they are, maybe. So they are kind of like rivers of strong wind in at the tropopause. Now, how strong is the wind? Well, maybe it's, 120 miles per hour to 180 miles per hour. So it is a pretty strong wind. You notice that these are westerly winds. So they go from west to east. Um, if you are traveling maybe from Los Angeles to New York and the jet streams happens to be going that direction, the airplanes will get in the jet stream and that'll help to blow them across. And they can save fuel and go a lot faster. If you're going the other way, going from New York to Los Angeles, then they're going to want to avoid the jet stream. They don't want to have that headwind and be fighting it. So maybe they'll go above the tropopause or lower or at just a different latitude to try to get around that jet stream. Well, what causes them and then kind of why are jet streams important for weather? They're caused by differential heating, which causes pressure differences. So you see in this animation, we have high pressure here, low pressure here. Where they're spinning, it's going to make it really fast going through here. You might have seen a machine like this that pitches baseballs or pitches footballs. And you have two big wheels going opposite directions, and you put the baseball or football in the middle, and it goes whoosh, really quickly through it. That's basically what the jet stream does. Okay, you have your high pressure, your low pressure, and it speeds going through it. So it goes around the Earth. Like I said, it's westerly, it goes west to east. There are about 5 or 6 of these loops usually. Now, how it's important for weather is the jet streams usually separate air masses. So you see in this picture, north of the jet stream, usually it's colder air. South of it, it's warmer. We look at this big picture again, and we think, okay, it's summertime. The Earth is tilted away or tilted towards the sun in the northern hemisphere. So these jet streams shift upwards. The polar jet stream shifts way up here. The subtropical jet stream shifts way up here, maybe. And in Texas, we are hot, hot, hot because we're in this really, really hot air. We don't get kind of the moderate medium air, and we certainly don't get the cold air. So our summer is usually very hot and very dry because this jet stream is way above us. Okay, it would bring the cooler air down, and it would also bring storms. In the wintertime, it's the opposite. We're tilted away from the sun, so these jet streams shift downwards. So the jet stream shifts down this way, the polar jet stream shifts down, and we're usually between the two. So we get kind of mild winters. Sometimes the polar jet stream will actually dip below us. Then we have the really frigid days where we get into, to the teens, and we get the ice storms and things like that. So it really kind of affects the temperature of a location because these jet streams tend to separate the air masses and storms kind of follow them. If I click on a weather map, we can see, you can look online and see where the jet streams are on any given day, and they can give you forecasts also for where the jet streams are. So here's one for this day. You see a jet stream happens to be going here. Arctic weather up here. This day is actually January 29th. Today in Dallas, it was only about 30. It was an 18 for a high, but up here it was like negative 12, negative 20s. So Arctic weather up here, you can see it separates different air masses. Then they have a forecast for the next day. So you can get forecasts for where the jet streams are going, and it will, like I said, affect the temperature. And that's really pretty much it for our little short lesson on jet streams.